Good afternoon. It's a little loud. How's everybody doing? All right. We've reached the part of the semester where you can judge dedication by who shows up to lecture. I appreciate your dedication. On the other hand, I'm only asking for 1 day of dedication from you a week, which seems easy. You'll be judged more harshly this semester than I would have in the past because of that, I think. Midterm started? This week? Last week? This week? Okay. We have a midterm sometime. I should write that at some point. It'll be good. It'll be the best midterm. So, you had 2 readings to do this week. One was on input devices, and one was on prototyping. I'm going to focus today mostly on the prototyping part because I mostly don't want to talk about the input devices thing. Maybe we'll come back to it at some point, but if you have any questions on that, just talk to me in office hours. It's one of those readings that I think is interesting, but not really what I want to talk about in class, so we'll come back to it if you want. But to give you a little feel for input devices, today's UI to critique is a input device sort of thing. So ponder this for a moment. Anybody seen one of those in real life, like out in the world? They do sell them. You just don't see them around. Any thoughts on that as an input device? Anything you want to critique about that or like about that? Yeah. Indeed. It does look tremendously like a kind of Kickstarter and done type of project. But why? Why wouldn't that take off? Yeah.
I think it also requires a lot of getting used to type that way and know how to blind type, something like that. Don't look at the keyboard.
Okay, so there's a learning period, right? And it's going to be challenging to introduce any new technology that has like a harsh learning period. Yeah.
So proportionally, it's not the same as regular keyboards.
Okay.
So as a user of regular keyboard, if I'm using that often and I go to use that one, I might have some difficulty switching back and forth.
All right, so switching back and forth between a full-size keyboard and that thing might prove challenging. Please.
I think that the reason it would be a popular Kickstarter thing is because it's novel in a way that's familiar and just looks cool to use. But if you think about when you would actually use it, then the number of users that would actually use an iPad to type a lot, there's not many of those. Even many people just use a regular laptop.
Yeah, so it's kind of solving a problem that doesn't actually exist, right? That's where people get themselves in trouble with these Kickstarter projects, is when they figure out a technology and they're like, I could do X. And they don't really slow down and say, like, does anybody want X? Does anybody need X? Would people buy that? And so it gets in this kind of gray area of like most people either are perfectly comfortable typing on a phone or an iPad and they just do it, or that experience is so foreign to them that instead of even trying to do that, they would just go to their desktop or to their laptop. And it's not real clear to me that there's a lot of this kind of gray area in between where people want to be working on an iPad or an iPhone, but want that kind of physical keyboard. It does have magnets. Products with magnets are always super cool. Anything else? Okay. So where are we in the kind of design cycle? If you haven't noticed, the theme of the first half of this class is that we're kind of walking our way through the design process, both in these lectures and in the assignments, the group assignments that are coming out right now. If you haven't noticed, you have another group assignment due soon. And the process here, I told you this class had a bunch of work to do. Can't say you weren't warned. So we did this design thing, sort of. We talked about how do you design products by going out and observing existing practice and talking to people and doing task analysis and contextual inquiry and this whole kind of process that we were working through where you go out and you learn about your users and their needs. And then we talked about how you inform that process through models. So the past kind of week and a half worth of material, including the input devices reading that you guys did, is all about how do I know what to build based on information that I can kind of gather from other sciences. How do I build models of human performance and human behavior and cognition and use that to inform my design process. So that's all about kind of being a more informed designer, and it's in the blue part over here. We're now going to head into the yellow arrow, the prototype phase. And while that is, I think, the most interesting and the most important part of the design cycle, it's actually probably what we talk about the least in this class of the whole process. And the reason for that is that it is the most similar to what you would be exposed in the rest of your computer science career or the rest of your engineering career. The prototyping process is sort of just engineering. It's the engineering process. But we're going to talk about it kind of from the angle of designers doing prototyping work. So imagine that you don't have any computer science skills. Easier for some people in this room to imagine than others because you're not all computer scientists. And that you're looking at this from a sort of perspective of I'm a designer trying to build something that communicates to engineers or that communicates to the world. And how do you go about doing that? So to start out, just a little background on prototyping theory and why it's important and why it's worth doing. What is a prototype? Somebody, anybody. What's a prototype? Sure.
I would say it's like a small, well, it depends on how you look at it. It's just a concept, or the beginning of a concept put on tangible format.
Okay, so it's a tangible version of an early stage concept. I like that. It's a reasonable definition. Sure. Okay, something built to illuminate the path in some way or another from here to your end goal. What else is a prototype? Well, this is all heading in the right direction here. So I have a few kind of canonical famous definitions of prototypes here. A prototype is the means by which designers organically and evolutionarily learn, discover, generate, and refine ideas, refine designs. It's from Lim and Stollerman's The Anatomy of Prototypes. That's a famous book. It's a representation of a design made before the final solution exists, kind of getting to this direction. And it's producing early working versions of the future application system and experimenting with them, says Lichter. And the idea here fundamentally is that prototypes are about getting feedback. Prototypes are about building the thing that feeds into the evaluation part of the design cycle that will allow you to learn about what is working in your design and what is not working in your design and improve it going forward. So it's all about getting feedback. And there's this interesting thing. Prototyping and kind of professional product design, product engineering, didn't really come about until mass production came about. There was, centuries and millennia before mass production of craftsmen making kind of artisanal goods, one-off goods. And there you typically have, a person making an item. And sure, they get better at making that item over time. They, in successive generations of it, but they don't typically build a prototype and then test with that prototype. They just build a thing and they sell the thing. And the reason that prototyping kind of came into being is suddenly, if you're going to turn around and the first time you go to sell something, you're going to have produced thousands of them, tens of thousands of them, it's suddenly really scary. There's this really big hurdle that you're jumping over where the thing that you're producing 10,000 copies of better be the right thing. And so this kind of science of prototyping came about in this era of mass production. This is a famous early example of prototyping when they were building the early kind of commercial passenger jets. Nobody had any notion of like, how is this experience going to work? When you build the first airliner that's intended to hold more than 2 people at a time, how do you do that and what does it look like and what does it feel? And so they spent, while they were working out the aeronautics and figuring out how you actually make a jet fly, at the same time, the kind of ergonomics people involved in that industry were building these prototypes of jets on the ground that are just the fuselage, just the tube bit of the airplane, and then going in and testing how do people get on and off of a plane? How do people want to sit? Can people sit for 6 hours at a time without losing their mind? Questions that they didn't actually know the answer to because nobody was doing it yet. They were able to answer on the ground using these types of prototypes. And then there's a famous book by Henry Dreyfuss that is all about prototyping in the space of industrial design and product design. It's worth going and checking out if you're curious. But this was kind of the birthplace of the prototyping movement, was this process that he invented that was like, go out, see what people are doing, observe existing practices, build a thing, take the thing out and test and see how it works. And his model for how you go out and do it looks like this. Understand the world, observe the world, visualize a solution to a problem, prototype the solution, evaluate the implementation of the prototype, and then when you've done that for a few cycles, go out and build the real thing and see how it changes the world. And you'll notice that this fits in really nicely to our kind of higher order abstraction of how this process works, of design, prototype, evaluate. This is kind of this tight loop in here of like, visualize the change, be the change, test the change, is how we see product design as a process. Any questions about that? Why we're doing prototyping, what the point is? Green tea, way better than whatever that was I had last week. So, the value of prototyping, why do we go out and we do it? The basic benefits are threefold. One is that designers know more than they can tell, and I'll talk about what I mean by that. 2 is that actions in the world outperform mental operations. And 3 is the value of surprise. And that really is, we've talked the past few weeks about models and models of human performance and models of how the universe works. If you get too stuck in your models, you can forget that people are really, really weird and that people will always do things with your product that you didn't expect them to do with your product. And so just getting the product out there in front of people and seeing what happens, being ready and willing to be surprised when things don't work the way that you think they're going to work, is a big part of why we actually do prototyping. And so there's this notion of tacit knowledge for designers, and the fact that we as designers or we as engineers or we as just people in general can do a lot of things that we can't explain. It's why people are not always necessarily great teachers, even if they really well understand something, because doing something is a very different skill than actually going out and explaining it to someone else. And so the point of prototypes from this perspective is that if you, the designer, know what it is that you want built, you can actually just go out and build it instead of trying to explain it to an engineering team or explain it to a contractor or explain it to your graphic designer. If you can get as far along the path towards the real thing as possible, you can then take that artifact and show it to somebody that can take it the rest of the way. And so this is kind of prototypes as a communication tool, prototypes as a tool to explore the space with the help of your engineering team. And again, that's kind of the interesting thing about this in this context of this class is that many of you have the skills to take these things all the way to production, but that's not usually the assumption of a designer. Usually when you think about a UX designer, you're thinking about somebody that can get to a low fidelity prototype, but not to a high fidelity prototype. And so this is about showing the rest of your team what it is that you really have in your head for how the design should work. And then there's this other notion of people actually think using the space. People think using physical artifacts. So there's this famous experiment done in the HCI literature 10, 15 years ago, where they had a bunch of people play Tetris, and they wanted to see how good Tetris players are different than bad Tetris players. What would you guess is the primary difference between good Tetris players and bad Tetris players in terms of how they interact with the controller, what they do while they're playing Tetris? Yeah. Okay, they do a little bit of that. There's more motion in good Tetris players. There's one other thing now. Anybody here a really good Tetris player? Yeah. So they don't have to think about the controls. Not what I'm going for. Yeah, so you can flip them clockwise or counterclockwise. I see. I think they were given like an NES controller in this particular thing.
Think about maybe to have a mind model on how things move before they order to fit in the spots.
Okay, you're close. So it turns out that really good Tetris players are really twitchy, and they sit there just going back and forth on the A button and the B button, just rotating the piece. So they just sit there and they the piece the whole time. And the reason is the way their brain is processing the problem is they are looking for matches between the actual physical piece on the screen and where they want it on, in the Tetris thing they're building. And so they sit there and they twiddle the pieces until they just mentally get it in the right place, and then they hammer it home. And so they go and play with the pieces in that way, in a way that, sorry, my phone is blowing up on me here, in a way that other people, novices, don't do. And so it's about kind of thinking about problems by actually interacting with the space, and that's what we're trying to capture in this kind of spirit of prototyping. And so you read a paper last night that was called The Purpose of Prototypes, or What Do Prototypes Prototype, that sort of thing. We are going to talk about a different set of reasons for prototyping, and then we'll get into that one. But first, the kind of high-level questions here are, what questions do prototypes answer? Why do you have these things, and what are you trying to do with them? And when and how should they be constructed? And we have this kind of flowchart, this one way of describing the world of prototypes that tries to answer this question: what is the purpose of a prototype? Understanding existing experience, inquiring actions, quote unquote, and communication. And I'll just walk through each of those real quick. So understanding existing experience is about the task analysis process. It's prototypes that help during the kind of formative design process rather than late in the design. And they are prototypes that help you learn something about the universe, learn something about how the world works, rather than learning something about your specific design. These are sometimes called technology probes. They're things that you build to learn about the world, but not to learn about your design. And so here's one related kind of famous example. There were a bunch of people when smartphones first came out that were trying to answer the question, how will touchscreen-based smartphones end up working out for people whose hands are less dexterous than 23-year-olds might be? And how, so how do the elderly, or how do less capable, or different people interact with these devices? And so they gave people phones and prototypes of phones. They sent designers out into the world, but they told the designers they had to wear mittens for like 2 weeks of gloves, little fuzzy gloves. So they gave their designers fuzzy gloves, sent them out into the world and said, good luck, use your phone as is for the next 2 weeks with the little fuzzy gloves. And in this case, what they're trying to learn about is not their design. This wasn't their phone they were designing necessarily. The prototype here is actually the experience of interacting with the world while wearing these fuzzy gloves. But it's a way for them to learn about what that's like, to be a little less dexterous and to have, be less capable of kind of pointing at specific places on a phone. Another way of doing this is what's called a guided exploration. So imagine in this scenario that you are a team of designers trying to redesign the experience of being on a train, of taking Amtrak from Sacramento to LA or something. One way of exploring that space is to get all the designers in there doing the thing that they're supposed to be doing, in this case, riding the train. And if you remember from the contextual inquiry reading, there's this problem of doing contextual inquiry, which is that not everything interesting happens every day, right? If you sit there and you watch, a software engineer do their job for a day, you're not going to see all the weird things that happen to that person over the course of a year. You're just going to get some random slice. And the same thing goes for going out and actually experiencing these things yourself. If you go and take the train from here to there, you may not experience all the myriad of different things that a person riding the train would experience. And so these cards are about helping people that are the actual designers experience the breadth of things that can happen while going on the train. So if somebody walks up to you, the person running the experiment, you're a designer riding the train, and hands you a card that says, be hungry, try to find something to eat. They are just interjecting into your experience here something that could happen to you. And so in this particular case, it's less what we're referring to here as the prototype is like this whole situational experiential design thing where somebody is coming up with this kind of fabricated experience for the designers to be able to go out there and actually feel what it's like to be the person riding the train. That makes sense? That got rambly, but believe me that this makes sense. It's a thing that people do fairly often. Yeah.
Who would conduct something this kind of experiment and will trigger something like that?
Typically, this would be like a design consultancy that's been hired to come in and redesign an experience. So say that you were IDEO and you got hired to redesign the Amtrak experience. You might bring your team of 20 IDEO designers for a few train rides and then do this sort of thing during that so that everybody on your design team gets to experience this. And then when you go back to the brainstorm, they're able to say like, yeah, but what if the person's hungry? Like, if you're hungry, this design doesn't work. That sort of thing, just to kind of broaden out the experience of your team.
So the next question would be, is it required to know a little more before you do something in an experiment like this? You need to know about that particular train and the people that are going in the train.
Right, so somebody needs to understand the breadth already, right? And so typically you would have a task analysis process where one person or some small team of people went out and kind of learned about the breadth of activities. And then when you bring your bigger team to start thinking about the engineering or the design solutions to the problems, this is kind of a way of using a quote-unquote prototype to communicate those challenges from the task analysis to the broader team. Good questions. Anything else? All right, and then we get into what we typically are thinking of when we think of prototypes. So prototypes that are intended to inspire inquiring actions. So prototypes that explore, experiment, and validate different design options. And again, everybody in the world has their own little model of like what prototypes are for. This one is IDEO's. So IDEO talks about prototypes that inspire future designs, prototypes that help you evolve incrementally in existing design, and prototypes that help you validate your design once it's kind of half-baked. And what's interesting about this chart is, so this is the number of ideas you're currently considering, and this is time and kind of polish. So you start with a lot of ideas, you make little prototypes of them on paper or on sketches. You use those to inspire the next round of prototypes by getting really quick feedback, and then you start narrowing down the ideas and narrowing down the ideas until you have just a couple of really good ideas left that you're trying to polish up to get closer to production. Yeah, sure.
So brainstorming would go into the inspired part.
So brainstorming is kind of actually in each part here. Imagine that there's this whole design, prototype, evaluate loop going on over and over here. And at each successive prototype stage, you're doing fewer and fewer prototypes of higher and higher fidelity. That's kind of what this is describing. So here's one example of this. Can anybody imagine what this is a prototype of? No. Way before me. Although it does kind of have that look. Yeah. Yeah, so this was a prototype digital camera that IDEO did back before digital cameras were a thing. And the way they actually built it was they did some injection mold plastics, they slapped some buttons on dials and things, and then they actually had this big ass cable going to a computer because they didn't have any way to actually do the digital camera bits in a mobile hardware solution at the time. So instead they had to just run a tether out to a computer. But they were able to answer a bunch of questions about, like, what do people want to do with the screen on a digital camera? What should the buttons do on a digital camera? How do we kind of fundamentally design this thing from the top down before we really are actually capable of building the damn thing? And so that research that they did, which they did several years before it was actually practical to make a digital camera, ended up really informing the design of that first generation of digital cameras when the technology became feasible. Cool. Look at a couple other explorations of spaces. So industrial design has this like massive sprawl of prototypes meant to explore and kind of validate. So when they were building the new Microsoft mouse, which was like the mouse of the early 2000s, they built just hundreds and hundreds of these mice prototypes in clay, 80 models that this one dude did, to really quickly just explore different possible shapes, get them in people's hands, see what people do and don't like about using these types of systems or using these types of devices. So it just allows you to really rapidly knock out a bunch of prototypes. Anybody know what that's a prototype of? What's that? It's a Mac desktop, but it's not what they were prototyping. It looks like a video conferencing system. It's not what it is. There are a bunch of them in this room. I can tell you that. Yeah, so this is like iPhone prototype number 1. They took an actual phone, wired it into a board, plugged it into a Mac, desktop Mac, put a little electronics exchange box in between it, hooked up a speaker, and you've got an iPhone. And so they would actually bring people in to say, all right, pretend that this is all one device, not a sprawl of stuff on the table. Make a phone call, or click the button that you would click to look at your contacts. And they actually designed a lot of the iPhone user interface on this screen using just a mouse and keyboard for input instead of the touch screen, with all this sprawly crap sitting on the table, so that when somebody said, like, okay, now I would take a picture, they would like send them over to camera land. And when somebody said, now I would make a phone call, they sent them over to phone land. And so this is kind of how you start nailing down design details of a system that you don't actually know how to build. That's the point of the story here. And then they rapidly kind of whipped through just hundreds of these prototypes of, like, what if it was shaped like this? What if it looked like this? Boom, boom, boom. They just kind of cranked out hundreds and hundreds of these potential iPhone designs before finally settling on what became the iPhone 1, which is kind of that looking thing. All right, and then this last bit of prototypes is actually what I do mostly for a living at this point, which are prototypes to communicate, prototypes that feed the business development or the executive side of business operations. So there's this famous example of Lisa Reichelt, whose last name I can never say. Reichelt. You have to. It's a throaty sort of thing. And she was the lead designer for a long time at Drupal.org, and came up with this what became rather famous process of going out and building one prototype a week or one handful of prototypes a week to show to the Drupal community. And so they would just put out their designs, show them to the community and say, what do you like? Do you like this? Do you like that? Should it look more like this? Should it look more like that? And it was a way to kind of ground community discussion. Drupal very deeply believes in we are not telling you what it should look like. We are building it as a community. And it was a way to ground that discussion. Here are our prototypes. What do you guys as the world think we should be doing here? And then that would actually guide the engineering work for the next couple of weeks. And so this really deeply engaged process of designers working with the community. All right, how about the paper that you actually read this week? What were their answers to what do prototypes prototype? What are the 3 purposes of prototypes in that framework? That would be a good midterm question, I'm just saying. I have to come up with something for you guys to do on the midterm. What do prototypes prototype? Somebody. Yeah. Yes. Role, look and feel, and implementation. So it's this notion of you go through this cycle of kind of very abstract, high-level, quote-unquote, role prototypes, which are about, what does the system do? How does it, play a function in the user's life? How is it useful to a person? Then into this look and feel thing, which is about kind of the concrete experience of actually using the thing that you're building, what the user looks at, what the user feels, what the user hears, how they actually interact with it. And then the implementation type of part of prototyping is about actual algorithms and engineering techniques and functionality. How do you actually build the thing? And so there's a lot to be learned there too. And that's another thing that I think is important to kind of keep reinforcing here, is that prototypes are useful for a lot of different players in the design process. The kind of high-level user experience designer is thinking mostly about role and how the device fits into the person's world, and so they're building that type of prototype. But then the engineers need prototypes too, right? You don't just magically spec a thing out and then build the final version of it. And so a lot of the kind of technological questions and how do I actually write this thing in software get answered in engineering prototypes. So here's kind of what we mean by a very abstract, quote unquote, role-based prototype is just a sketch that says, here's a 3D space planning application. You would be able to look at a room and you would have chairs and you would be able to drop the chairs in where you want them to be. And you could take this thing just as a sort of paper prototype, go out into the world and say, would this be useful to you? Would you use this thing? Then you can start getting into look and feel. It's going to be a 3D model. We're going to be able to rotate the thing. And then you can get into the actual implementation details. And so, again, there's just all these different ways of talking about what are prototypes for, what do prototypes prototype, and who uses them. Everything we've talked about so far is more about breadth, how many different ideas do you want to cover in one prototype, and what are you trying to test with them? The other kind of axis here is how deep is the functionality of a prototype. So you can have partial prototypes that are just little bits of your application, or full prototypes, and then you can have low fidelity mock-ups, Wizard of Oz type simulations, and all the way up to working high fidelity prototypes. And we'll talk a bunch today about Wizard of Oz and paper prototypes. And then the studio activity today, which we're going to spend quite a bit of time on because I think it's fun, is going to be to do a Wizard of Oz style paper prototype. So we will start there. Paper prototyping. This is a paper prototype that I built for testing a mobile application at one point. We were trying to figure out what the layout of icons should be, and so I spent a whole day in a cafe somewhere buying people coffee for them and asking them to sit down and play with different paper versions of this particular user interface. Here is a quickie video from the Nielsen group about what paper prototypes are all about.
This video contains instructions for creating paper prototypes and demonstrations for testing them. We offer tips and supplies you can use.
Simple widgets can be simulated well with paper. However, simulating complex interactions is a little bit more challenging and not perfect. Prototypes that look closer to the final product can provide you with additional data that low-fidelity designs cannot.
This video shows how an application for a mobile device can be tested by using plain white paper.
Paper prototyping is not only for websites and software. This technique can be applied to hardware and three-dimensional interfaces as well.
Paper prototyping is a great way to test your ideas early.
So they're trying to sell you a product there, if that wasn't clear. They want you to buy their video on how to do paper prototyping. And I just accidentally cheated Jacob Nielsen out of 20 bucks or something by just showing you the advertisement instead of the actual video. Anyway, this is what we're going to talk about today, is how do you do these sorts of paper prototypes and Wizard of Oz style things. And so what you do when you want to build a paper prototype is you just get a bunch of paper, a bunch of index cards, some Post-it notes, tape, sticky notes, glue. It's very kindergarten level skills, which unfortunately I was super bad at kindergarten, which is a challenge when I go to do paper prototypes because I can never draw anything that anybody recognizes. But, oh well. Transparencies, scissors, X-Acto knives, all these sorts of things. And you just go out there and you start building things on paper. So you draw screens using paper. You draw individual widgets or buttons or scrollers or whatever the hell else you want to build as kind of individual components on their own little individual pieces of paper. So you get together all of these kind of interface elements. And the idea is that you just start slapping things together. If you have multiple screens that the user can navigate through, you sit them down, you put the paper prototype in front of them, and you say, all right, what would you do? Pretend this is a real phone, pretend this is a real website. Tell me which thing you would try clicking. And they say, okay, I would click this next button. And then when they click the next button, you say, okay, let me put that screen in front of you, and you just swap them. And that's sort of what we mean by Wizard of Oz. We'll get into a little bit more detail in a second. But there's this, who's seen The Wizard of Oz? Do people still watch The Wizard of Oz? Wow, that's bad. We need another name for this? Okay, spoiler warning. That's bad. Like, I can't spoil The Wizard of Oz for you. Anyway, there's, all right, I need a vote of GSIs. Am I allowed to spoil The Wizard of Oz for people that have never seen the... Okay, they say no. So, anyway, there's this method where in Wizard of Oz, you talk about things that aren't real. You make things happen in the world that aren't actually possible. And so the Wizard of Oz technique, we saw in that video there where the person had hit the button for the coffee, and then he looked away for a second, and the designer was like, whoop, and swapped in like a cup of coffee that was actually full of coffee. That's what we're talking about. Like, there's somebody there that is able to do the things that the computer is supposed to be doing in the real world. We see this a lot with like text-to-speech engines when you're prototyping them. But anyway, we'll get into that in a second. And so you get in there and you build your prototype. You set a deadline. For instance, here in a few minutes when we do the studio activity, you'll have like 20 minutes to build it because you don't want to overthink it. You just want to go out there and build the damn thing using paper. You draw your window or your mobile device or whatever on a large piece of paper in whatever aspect ratio you want to use. And then you put your different screen regions or buttons or components or whatever on different cards, and you just get ready to respond to user actions. You're trying to build out the whole user interface in paper in a way that you can play computer and swap the things in and out. And so we do this sort of Wizard of Oz testing where a person sits there and plays computer. And when you say, I click next, you actually do next. You could imagine the programming assignment 2 that's due tomorrow, doing this as a paper prototype. You would have your little paper next button, and when the person says next, you would take your XKCD comic and you would flip in the next one, right? And if they say random, you would randomly pick one out of your pile. And it's this notion of just kind of simulating what the computer would do while interacting with the paper version of the prototype. And there are these kind of well-defined roles. You have your user, who is your kind of random person that you bring in off the street. We'll talk more about how you get those next week when we talk about experimental design. You have your interface, which is the paper thing. You have your kind of pile of interface elements that you're ready to swap in and out. And then you have your person that's playing the computer and actually sits there and does the thing. And then the observers who are sitting there taking notes, trying to figure out what's working and what's not working. And so this is all about just kind of how you actually conduct these things. You have the person who's friendly and greets them and gets them to sign their NDA and all of that sort of bullshit. You have the facilitator who actually talks to the person, gives them the instructions and walks them through it. You have the computer person who is actually moving the paper prototype. And one of the key things is that the computer doesn't talk, right? Because computers don't do that, at least not in the types of things we're prototyping here. And so the computer is supposed to be dumb. The computer is supposed to be only doing things that the real system would be doing. And then you have your people taking notes and videotaping and all of that. And it takes about an hour. You have somebody come in, you brief them, you run your experiment for half an hour or something, and then you debrief them. There's a bunch of details here. It's not that interesting, I don't think. Again, we'll talk about experimental design some more next week. But the key thing to know when you're doing paper prototype testing and really any type of formative design testing is what's called the think aloud method. So if you actually only learn like 2 things from this course, contextual inquiry is one, think aloud would be the other. It is a mechanism for getting somebody to use a piece of software or a prototype of a piece of software and to explain to you what they're thinking and what they're doing. And so conceptually, you just want them narrating everything that they do. So you want them, as they're looking at a screen or looking at this device, if I were the experimenter, if I were the designer, I would be saying, okay, imagine that you want to go to the next slide. What would you do? And they would look at this for a second, and I would say, what are you seeing? And they would say, well, I see a button with a left arrow and a button with a right arrow, and I'm going to click the one with the right arrow. And I would say, why? And they would say, well, I think that maybe it indicates with the right that that's going to go to the next slide. And I say, okay, go ahead and click it. And they would click it, and you just keep them talking. It's this super, super obnoxious method of just sitting there and saying, what are you doing? Why are you doing that? What do you see? What do you think? What is going through your head? And people resist it for like 2 minutes. And then once you have them 2 minutes into doing it, they can't stop. It turns out once you start narrating everything you see in your life, it's an experience that sticks with you. And I often will run these experiments, and people will keep doing it after the experiment is done. Like, you'll be walking them out of the room, and you'll say, like, thank you. And they'll be like, that's a door. Doors have handles. I can open the door using that handle. It's like, okay, tone it down. Back to real life. But anyway, it's kind of a fun thing to do. If you ever want to just have some fun, grab a random friend and get them to think out loud while they're using something that they already know how to use. It's very interesting. But we'll be doing a little bit of that today. So when you do your studio activity and your user, which will be one of the GSIs, is walking through the user interface, try to get them to think out loud. Try to get them to narrate their experience with their user experience. Okay. One little note on experimental design here. Make sure that you recruit people that are at least quasi-representative of who your target users are. So, if you're building a system for elderly individuals living in retirement homes, don't go and test with like random people on campus. Like, it doesn't work that way. Try to get people that are representative of your actual users. Don't use friends or family. Do take surveys of kind of demographics and background of people so that you can control for certain variables. Prepare tasks. So when we talked about the kind of task analysis part of this course, I mentioned that the tasks keep coming up again. This is the next place where they show up, is in the kind of experimental design of formative evaluation. And so figuring out like what people will do with your interface and being able to explain that to them. So if you made a paper prototype of a music player, you might say, okay, imagine that you want to find a playlist named Chiptunes and you want to shuffle play through it. That would be the task that you give to the person, and then you ask them to work through that task while kind of doing the think aloud method. Make sure you practice a little bit playing computer, because it's tremendously difficult actually to run a paper prototype. And every time you screw up, you break the illusion a little bit. People can start getting in the headspace of like, this isn't ridiculous, this actually makes sense, we're working with this system. And every time that you are bad at executing with it, you take them out of that. Cool. On the Wizard of Oz side of things, it often helps if you have a lot of notes on kind of, if they press this, go to section 27, go to this particular page, and be ready to swap those things in and out. Like I mentioned, Wizard of Oz is often used for things that are difficult to prototype. So say that your system that you're building inherently needs speech recognition, but you're not sure if you're even building the right thing. Rather than going out and like doing all the work to hook up a speech recognition system, it would be a lot easier to just have a person there who speaks English and is able to respond. But you have to be careful not to imply a level of sophistication in your interface that won't be there in the real thing. So if your system isn't really capable of natural language processing, just like raw speech recognition, simulate your paper prototype in that way instead of in the more complicated way. Stay in role, and the facilitator's job rather than the computer's job is to keep prompting on the think aloud part of this, keeping people engaged in the study. And then what you actually are looking for, the whole point of doing this, is looking for what we call critical incidents. So in any user study, whether you're doing it with a paper prototype or like the real thing, the idea is that the person is sitting there with the prototype, they're working their way through it, they're talking about what they see and how they're interacting with it, and you're looking for places where they get stuck, unusual or interesting events, because these are, where the usability problems are, is when people are having trouble completing the task that you're trying to get them to walk through. So when they get stuck, when they suddenly understand something that they didn't understand before, when they say, oh wow, that's cool, or oh God, why does it work this way? Any kind of utterances that they make that are indicating their state of mind are really interesting in terms of critical incidents. And the number one biggest thing you're looking for when you do a think aloud study with prototype is places where what they are saying and what you know to be true about the universe are different. So for instance, if they are looking at your XKCD viewer and they look at the button that you intended to be the back button, and they say, well, I don't want to click that because that button will leave XKCD, or that button will take me to a random comic, then you know that there's some mismatch between your model and their conceptual model. And really that's what we're looking for in these types of studies, is places of mismatch between various models. So you go out, you do that, you record your critical incidents, and then you update your task analysis, you rethink your design, you go back through this whole process again, you try to fix the problems that you've identified, and you go out and you build the next thing to test. And you just keep doing this process again and again and again. One important thing to note is that this kind of think aloud method of working through a prototype is not a mechanism for redesign. You're not asking your user what should it do, or how should it look, or how should it feel. You can't ask that. But you have to expect that the answers to those questions won't be particularly interesting. You're the designer. It's your job to do the design work. What you are looking for is problems, mismatches between your worldview and their worldview, and you're trying to use those as fuel for the next redesign, the next part of the process. Questions about that? Yeah.
So the experiment or the user,
Mhm.
is he supposed to be let know what that experiment is going to be about, or okay, I'm going to show you an app that is going to do this. It's supposed to do this,
Mhm.
or you're just like, here's this.
Totally depends what you're trying to accomplish, right? So if you have a limited amount of time and you really want to get at some particular usability problem, then yeah, you would give them a bunch of context and you might even tell them how some parts of the app work. If instead you're trying to answer kind of general discoverability or readability problems in your app, you might just say, like, pretend you just downloaded this thing from the App Store and you're trying to figure it out. Go. And so how you design the tasks that the user does during the user study really informs the type of input you get back for the design process. Other thoughts? Questions? Need to do jumping jacks or something? We're all lagging today, me included. All right, so that's paper prototyping. I also want to mention prototyping in software. So as we've said, there are kind of these granularities of prototypes. There's these different levels of polish, and you might start at something super, super low fidelity like a paper prototype and build your way up to something higher fidelity, and eventually you're going to get to like software and a full implementation. And there are steps in between those two things. So we're talking about level of detail here, how much the prototype looks like the final product, and how much it feels like the final product. And there are pros and cons to these different things. In low fidelity prototyping in software, you are typically using software that is intended to replicate physical tools. So software that is intended to replicate paper and scissors and all of those sorts of things, while also giving you all the good parts of software, things like undo and copy and paste and resizing and duplication. And so what a lot of people actually do is build paper prototypes in Illustrator or in Balsamic or in Framer or in Figma or in all these different tools that we'll talk about in this course. And then they just print them out and run paper prototyping studies using things that they actually designed in software. So there's lots of different tools for actually doing that. And then you can start going towards the direction of higher fidelity visual mockups. So things that, like in the design world, we call comps that are going towards, what are you actually going to build? And those are interfaces that look more like the final application, may or may not be interactive, and may just be ways of paging between different static interfaces. So the types of things that you would build in Photoshop, Keynote, Illustrator. And there are good and bad things about high fidelity prototypes. So again, the type of prototype that you use is really intimately tied to what types of questions you're trying to answer. So low fidelity prototypes tend to encourage users to comment on really fundamental things. Like, is this app a good idea? Does the flow of this application make any sense? Are these buttons in the right place? That sort of thing. High fidelity prototypes, things like comps, on the other hand, tend to get critiqued on aesthetic choices or graphic design choices. Do you like this font? Do you like these colors? Do you like the way this thing overall makes you feel? And so you have to be really careful about what kinds of questions you want the answers to before you put a prototype in front of somebody. And the big thing to know is that people don't like hurting your feelings. Even if when you go out there and you do your introduction for a user study and you say, don't worry about hurting my feelings, I'm not the designer of this thing, I'm brought in to critique this thing and you're helping me with this, and all the different things that you're supposed to say at the start of a user study, still people don't want to like crush your fragile little spirit. And so they'll just lie to you if they hate your thing and they think that you worked really hard on it. And so if you show them a super high fidelity prototype and you say, what do you think of this thing? Would you use this? Everybody's always like, yeah, I would love this product and I cannot wait until it is on the App Store for 99 cents. But it's always a lie. Like if you show somebody something too polished, they want to be nice to you. And so a big part of low fidelity prototyping and a big part of why we do paper prototyping is that people are willing to critique those at very fundamental levels. Make sense? The same goes for the designer also, by the way. Like the more time you sink into building your prototype, the less willing you're gonna be to hear the like, no, this really sucks, you shouldn't be doing this. And so helping people kind of get feedback really early in the process is a big part of this. Slideware prototypes are a big thing. So if you've never done this in like PowerPoint, you can make links from different parts of a PowerPoint slide. So people will drop something that looks like the user interface into a PowerPoint slide and then make something like that checkbox a link to another slide. And so when you hit that button, it goes to the next slide and shows what the interface would look like after you hit that checkbox. So again, on the XKCD app that you're building right now, you could imagine having a slideware prototype of that, where hitting the next and back buttons just takes you to different slides in a PowerPoint presentation that have the different images for the XKCD comics. And there are all these libraries. If you just Google like PowerPoint Android widgets, you'll find like massive libraries of Android's look and feel that you can use in PowerPoint or in Illustrator or whatever. Okay, I think I'm bored now with that. And so eventually you build up towards this really high fidelity prototype, something that kind of looks and feels and behaves like the final application without necessarily having to do the back end sort of work to make it real. And this is kind of where we're trying to get to in this class. Like your final presentation at the end of this semester will be of this type of high fidelity prototype, where maybe there's still some bullshit happening behind the scenes in terms of how the actual back end part of your implementation would work. But all the front end stuff is there, like it's actually there implemented in software. And so the tools that people use for this sort of thing are things like HTML, CSS, and JavaScript, JQT, all the kind of Qt and Lua type libraries that help you really rapidly build interfaces, and tools like Canoma.js, like application frameworks that help you really quickly build prototypes. So again, just to hammer this home one more time, the reason we do lo-fi prototyping is that it's quick. You don't need any expensive equipment. You don't need a whole lot of training. You can really quickly test multiple alternatives, even with a single user. You can show them, you know, do you like this? Do you like this? Do you like this? You can really quickly iterate over low fidelity prototypes, and all of the research shows that the number of prototype iterations you have in your design process dramatically changes the quality of the final product. You can change the design as you're going without getting too tied up emotionally in what you're building. And it's especially useful to do low fidelity prototypes for things that would take a massive amount of engineering effort to actually build. The drawbacks of low fidelity prototyping are that it takes a lot of effort to kind of keep physically sketching things, although still less effort than would be required to actually implement it in software. At some point, you have to move from your paper prototype to software. So if you like prototyping in software, it can be easier to just start in kind of low fidelity software and build your way towards higher fidelity software, which is actually what I advocate for in my day job. And low fidelity prototypes don't necessarily lend themselves to real world interactions. Okay, any questions on paper prototyping, low fidelity prototyping, prototyping in software, any of this jazz? I have one more little section to get through and then we'll take a break. Thoughts, questions? Are you excited? Do you want to go build some paper prototypes? Be excited. Be excited about something. Be jazzed. All right, so one last thing I want to talk about is video prototyping. And the reason I want to talk about this is that you're going to very soon have, we're getting there, soon. Very soon you're going to have an assignment that is a video prototyping assignment. So right now the assignment you're working on is the contextual inquiry assignment. By the way, there's a contextual inquiry assignment out. If you haven't looked at B courses lately, go look at B courses. You have a group assignment. The one after that is going to be a low fidelity video prototype where you're going to build a paper prototype or a Figma prototype or a Framer prototype or an Illustrator prototype or whatever. And then you're going to take a video of it. And the concept here is basically, do you remember back when we did storyboarding? And we talked about like a really good storyboard shows the context. Like, it's a sunny day in Berkeley. There's a woman standing outside of Soda Hall. She needs to get to BART. Here's what her screen looks like on her mobile phone, and kind of does this like dig from the super high level into the detail and then back out to how whatever the person did in software changes the world. A video prototype is the same sort of idea, where you show a storyboard in action using video, and then you actually show off the interactions with the device as part of your video. So you show the paper prototype or you show the Illustrator comps or whatever in the context of how the person would actually be using the software out in the world. And I have a couple of examples of people doing video prototypes that I think might be useful to you going forward. So we'll just watch a couple of these. So that is one of the most prominent prototype engineers in the world. He runs Thingam and also the prototyping lab at Park. And that was a demonstration of like a little app that is intended to be the companion app to a smart wine rack. So you tell it, you know, I want white wines from California, and it lights up the white wines from California with backlight LEDs, that sort of thing. So that's a very polished version of this sort of concept of a high fidelity prototype sketch in video. Here's one from CS160 spring of 2010. A little less polished, but you get the idea. Oops. Oh. Yeah.
This is Mr. Dugan, a middle school math teacher. While he means well, Mr. Dugan can never seem to catch a break. His numerous students and classes cause him far too much frustration. He is looking for a simple way to track his students' attendance and behavior, all while in class.
I went to class, I have to take attendance, the students are going crazy, what am I going to do?
This is a job for both.
I'm not going to solve all their problems. Now I can take attendance and record behavior, please. But Mr. Dugan, your roster isn't in the iPhone application. Don't worry, I'll just sync it.
Mr. Dugan simply clicks the sync tab, selects his class, and taps an important file. Roll call takes a URL and does the rest.
Okay, let's take attendance. Mark Delmenco, Julia Nunez, absent.
To take attendance, Mr. Dugan simply taps the names of each student who is not here.
Who are you?
I'm Jordan, Dean.
Oh, a new student. Let me add you into my class.
To add a new student, Mr. Dugan edits his geometry class and clicks Add Students. Since Jordan is new, Mr. Dugan clicks the plus button to create Jordan's profile. Jordan is then automatically added to the class.
You're doing a great job. I'm going to give you a point.
A student's daily point value is accessed via the blue arrow.
Hey, you. No drinking in class. You're losing the point.
notes can also be accessed in this same menu.
Student, Mark asked the other day if I was here. Oh, sorry, Timothy. Let me check your records.
In the Students tab, Mr. Dugan has access to a full student's history.
Oh, it looks like you were here. Sorry, let me change that for you.
Mr. Dugan simply selects that date, clicks absent on the bottom of the screen, and changes the value.
Good. Today would have been a disaster without roll call.
I couldn't agree more.
So that's a rather well produced, actually, paper prototype, video prototype of kind of showing interactions with the paper prototype. And you can imagine that being used as a communications tool if you were pitching this app to a VC, if you were going out and trying to get people excited about your app. This is a way to do that in a super low fidelity, super easy to build, time consuming, yes, but not as time consuming as actually building software sort of way. So, any questions about that? Okay, trust me that it's coming soon. Assignments, exam, all sorts of good stuff. You had an assignment due yesterday. Hope you noticed that. Heuristic evaluation, that was due. Hope you did it. Programming 2 is due on Friday. That going okay? Doing all right? Too terrified? After Studio, if we have a little bit of time, I'll run through a few things that people are having recurring issues with. Be slightly less bad at JavaScript, and you will feel better about life. A lot of people are just kind of building individual templates for every single button in their user interface and doing things that you don't need to do. Yeah, there are ways to simplify your life. So we'll talk a bit about that. The contextual inquiry, task analysis, competitive analysis, group assignment is due next Wednesday. So make sure you're aware that that exists. It's on B courses. Go do it. The low fidelity prototype video will be the next assignment due October 17th. The midterm is the 20th. We will do a review session the week before the midterm. I think if everything works out the way I want it to, that's going to be what should be a pretty good guest speaker lined up for the first hour of that. And then we'll do a 2-hour midterm review, or we'll space it out or something. And then the third and final programming assignment will be sometime after the midterm, so you don't have to worry about programming for a little bit. It's a lot of stuff. Everybody doing okay? Excellent. I told you at the beginning of the class, like no single thing in this class is particularly hard, but there's just a lot of stuff. Like there's just a lot of steps to this process. Next week, we will talk about usability testing and data analysis. The midterm will cover everything up until the end of that lecture. So the midterm is basically full cycle design process from task analysis to data analysis. After the midterm, this class will go into a little fuzzier mode where we talk about HCI research topics and HCI practice, industry innovations, and then we're actually going to do project workshops in here for like 90 minutes basically every week, because I really think that most of the learning in this class, as much as I love hearing me talk, I think that most of the learning in this class is actually happening in the project and in the process of doing real design. So we'll focus on that throughout the rest of this course. Questions? Yes?
What's the format of the exam?
Good question. The format of the exam is paper and pencil. So basically it is, what I've done in the past was a series of short answers and then some design exercises. I have not even considered writing the exam yet for this semester. So if you have any requests for the exam, let me know. But probably that will be the format, is like a few pages of short answer and a few design exercises. Last time I taught this class, Lizzie can tell you that the midterm was way the fuck too long. Like people got like halfway through the exam. And so I'm going to try really hard not to do that again and have a more reasonable length of the exam. Other thoughts? Yeah.
To study, would we have to read all the readings again, or are we going to do the
there will likely be a thing or two from the readings in there, but I would tend towards more conceptual things from the readings and less details. So I tend personally towards details from the slides and high-level things from the reading, for what it's worth. But sometimes the GSIs write questions that are not exactly what I would have written, so fair warning. Other thoughts, questions? I guess that puts us, are we 3 weeks from the midterm today? Is that right? Cool. That's plenty of time to write a midterm, right? Anything else? All right, let us take a break and let's reconvene in like 7.5 minutes at 3:30. Don't leave though. You'll be sad if you leave because today's studio should be interesting.
How do I this thing?
Sure. How's this thing?
I made solitaire.
Sweet.
Hi, I have a quick question. Yeah. About the judging for performing too. I got injured last week because like I had an accident and I found out later that was a concussion, but I was like
Hang on.
that's horrible. I'm so sorry. Yeah.